Okay, this video is continue with the chapter 5.1 material. We are working on example number 8. This time we're looking for present values. A lot of time present value is kind of like your principal, what you put into the account. So this example says Stacy must pay a lump sum of $6,000 in 5 years. So Stacy is like trying to save up $6,000, and she has 5 years to get to that amount. So she wants to know what kind of money she need to put into the bank today, because you deposit it today, that make it present value, or this is your principal. If she can get 6.2% interest rate compounded annually, and she want whatever she put in will grow to $6,000 in 5 years. So I can expect like whatever she put in should be less than 6,000, right? Because you will make some interest along the way. So for number 8, this is chapter 5.1 again. Your present values basically is what your principal is going to be, and this look like compounded annually, so we're going to use the compound interest formula. Which is A equal to P, your book say 1 plus I, and I use P 1 plus R over N and T. Alright, so it would be helpful if you list each variable here, R, N, and T. So if you want to pause the video and see if you can list them correctly and plug it in correctly, feel free to do it. You can come back and check your answer. So basically, you want to get out $6,000. You don't know how much money to put in yet. You know your interest rate is 6.2%, but don't forget to change it to decimal 0.062, and the N is annually, which means once a year, and the T is time, which is 5 years. So hopefully you get that correct. And then we're going to plug it into the formula. A is 6,000. We don't know P, 1 plus 0.062 divided by 1 weighs to 1 times a year for 5 years. So 6,000. We can try to clean that up. This is basically just 1.062 raised to the 5th power, right? So I'm solving for P, so P need to stay, and I need to get rid of that. This is multiplying together, so the opposite will be divide 1.062 raised to the 5th power, right? 1.062 raised to the 5th power. So if you use your calculator, which we have 6,000 divided by parenthesis 1.062 raised to the 5th power, then this is your answer, right? So P is going to be about $4,441. If I round it up, it would be 49 cents, right? So this is saying that she need to deposit 4,440. Oh, I didn't write right. This is $4,441.49. So like if it's $444.49, it would not be reasonable, right? I should not get 6,000 out, right? So hopefully you look at your answer and make sure it's reasonable, so you don't make a mistake. 149 in the account under those conditions for 5 years, and then you will get $6,000 at the end, right? So hopefully that makes sense. So that's number 8. And let's look at number 9 after that. And anytime if you need to pause the video and work on it, don't worry, you can do that. Okay, number 9, look at this here. Okay, found the present value of $16,000 in 9 years if the money can be deposited at 2% compounded semi-annually. So again, present value pretty much means the principal. So number 9, and they say compounded semi-annually, so it means like we're using the compound interest formula, right? Alright, so your books say A equal to P 1 plus I N, and I like to use P 1 plus R over N and T. Alright, if you want to, you can go ahead and list those variables, and you can pause the video if you want to. Alright, so A is, so they want to get out 16,000, right? So 16,000, and want to find the present value, so I don't know present values. 9 years is my time, and if the money can be deposited at 2% is my rate, which is 0.02, right? And semi-annually means what? 2 times a year. Alright, so we're gonna need to plug it in. Go ahead. If you know, 16,000 equal to P1 plus, my R is 0.02 over 2 raised to 2 times 9. Okay, so hopefully that's what you have, and then we need to solve for P. So let's clean that up a little bit. P, if we do what's in the parenthesis, that would be 0.02, can you see, divided by 2 plus a 1, so that would be a 1.01, right? 2 times 9 is 18, so that's what we have. So again, both sides divided by 1.01 raised to 18 is going to be able to solve for P. 1.01 raised to 18. So use your calculator. 16,000 divided by parenthesis 1.01 raised to 18 power. So that's what I get. P should be about 13376.28 if I round it up, right? So that's my answer, which means if I want to get out $16,000 under those conditions, I need to deposit that much money. Okay, a deposit of $13,376.28 today under the given conditions will produce $16,000 in 9 years. So that's the power of compounding interest, right? So it's good if you can save up money and they give you those interests, but if you're borrowing money and they're charging you interest, it means you're paying a lot of interest too. So sorry. So that's what it is. Let's see, like I want to talk to you about number 10 and 11, like both of this equation, number 10, number 11 and also number 12C. Those three actually need to use log and natural log, which your book introduced those concepts on the very last exam, like exam 5. So we're gonna hold on to that. I can show you real quick how it looked like, but we're not going to test you over exam 3. Okay, so let's look at this real quick. Like on number 10, they are trying to find the time. Is compound interest. So if you set it up, if you're interested in like playing with that, you're solving for t, which is the exponents that you need to solve. So when we start solving it, you need to somehow bring down the exponents. For that, you will need the log property, which we don't introduce it until the very last exam. So I'm not sure why your book put this question here. I think they're just solving it with the graphing calculator by the graph. So once you have log, you can pull down the exponents, and at that point, we can solve it by dividing everything except the t to stay here. So number 10, I did it, and the time is going to be 27 years. So if any questions on the homework and the quizzes related to that, I will omit that, because right now they say focus on the most important stuff, and this is kind of out of the place. And number 11, if I can find the questions. Also, the number 11 is trying to find the doubling time. So for the doubling time, it also need to solve the exponents. So if you're kind of interested, number 11, doubling, we just like if you put in $1, you get $2 out. And then once you put in everything here, the thing you're solving is the exponent t up here. So at one point, you need to bring the t down by raising log both sides. So once you have that, you can bring the exponents down, and then you can solve it by dividing both sides with everything except the t stay there. So number 11, you will get a 9 years. But again, this log and natural log skill is going to be coming up in the last exam. So if you're interested, we can go back and revisit that. But number 12, A and B, you are responsible to know how to do it. So number 12, A and B. So C also need to use some kind of log, so we will hold on to that. But A and B, definitely you need to know. So let's try number 12, A and B together. So number 12 is about continuous compounding. So it's slightly more than daily, compounding daily. So this is still 5.1, number 12. They talk about continuous compounding. You're going to deposit $2,450 in an account that give you interest rate 5.25% compounded continuously. So when you do compounded continuously, we are using the formula A equal to PERT. Okay, so let's write down what we know on the side. So A P E R T. So the first question found the compounded amount and the interest earned after 6.5 years. Compounded amount is basically the future values, what kind of money you have in the account after T years. So that's A. So they want you to find A. We don't know A yet. Principal is what you put in, which is $2,450. E is E on your calculator, which is the natural number, and R is going to be 5.25%. Decimal point is 0.0525, right? And then T is going to be 6.5 years. Okay, so first we need to find A. So plug it in, please. and make sure you try it on the calculator. P is 2450, E, R is 0.0525, need to multiply by 6.5 years. Alright, so use your calculator. I like to do the exponents first. I mean, if you're very good at it, you can do it one step, but I do it step by step. 0.0525 times 6.5. So basically, I need 2450 e raised to 0.34125. So if you have a graphing calculator, E is going to be on top of ln, so you're going to need to use the blue button, second ln, to get your E, and then I'm going to put in 0.34125 as the exponent. So this part is 1.4 something, right? And don't forget, you should not round your number until the very last step. So I'm just going to be ... Keep that number in there. Just multiply 2450. And then your answer should be 3,446.43 after you round it up, right? So that's how much money you will have after 6.5 years. So I'm going to say this is your compounded amount after 6.5 years. Just one note, if you have a scientific calculator, when you use E, it's a little bit different. For my scientific calculator, is like again on top of ln. Instead of put it as an exponent like that, most of the scientific calculator, they just put that exponent next to the E. I don't know why, but it's work like that. Times 2450, so you get the same answer. But whatever calculator you use, make sure you practice it before the exam, so you will know how to use it. So number 12A also asks you to find the compounded amount and also the interest earned. So I also need to find the interest earned. How do we find interest earned? So interest earned is going to be your accumulated amount subtracted the principal, right? So you got 3446.43 minus my principal was what? 2450. Okay, my number is still there. Minus 2450 is going to be about $996.43 if you round it up, right? So that is the interest earned. So that's the part A. How about part B? Okay, so give you a second. Part B asks found the effective rate. So for the continuous compounding, the effective rate has a different formula compared to n times a year. So the effective rate for continuous compounding is not APY, like the one we did earlier is 1 plus R over n minus 1. So this is for n times a year. So for continuous compounding, the APY formula, effective R of E, most people call it APY, is going to be E raised to R minus 1. Okay, so we're looking for this formula, and then the information we have is the interest rate was 5.25%, which you change it to decimal number is 0.0525. So we plug it in there. E raised to 0.05 0.0525, and I need to subtract 1. So make sure you know how to plug it to the calculator. If you need to pause the video anytime to catch up, please feel free to do it. Okay, so my calculator, I need my E, which is second ln, right? And then 0.0525 on the graphing calculator. On the scientific, it's just next to the E. Enter first. So that's the number, and then I need to subtract 1, right? So that would be 0.053926, something like that. Okay, so because that's supposed to be interest rate, we need to move it 2 decimal places, so it becomes 5.39%. So even though it looked like 5.25%, the effective interest rate is a little bit higher. It is 5.39% if it was 5.25% compounded continuously. Alright, so the more you compound, normally it means like higher interest you will get or you will pay. And then for 12C, so pause it if you need to write down. For 12C, found the time required for the original from 2,450 to grow to 10,000. So again, this one we need to hold on to it because we need to use ln. I can show you real quick. So we use the continuous compounding interest formula, and then we plug in what we know, and we are solving for t, which is in the exponents. So we divide both sides with 2,450, and then to solve for the exponents, I need to raise both sides with ln. This time we raise ln instead of log because it comes with e. And ln e will equal to 1. So we bring down the exponents, ln e turn into 1. We divide both sides with this number, and we found out it takes about 27 years to grow from $2,450 to $10,000. So again, like once we talk about log and ln toward the end of the semester, we can come back and revisit this question. Alright? If you have questions, please let me know. We will have some meeting. You can email me also. Thank you.